Hi, this last video covers exceptions. This is a smaller topic than the topic of functions. In the input-output lesson, we did a bunch of asking the user for numbers. But what if the user enters something that isn't a number at all, like ABCD? Remember, I said that the int function will convert a string to an integer if the string really contains an integer. If it doesn't, this will actually crash our program. What this is actually doing is raising an exception, and a special type of exception at that, something called a value error. You can see the type of the exception written in the error message on the right. Let's look at another type of exception that can be raised. What do you think is going to happen in this program? Yep, Python doesn't let you divide by 0. We saw this in the lesson on short circuit evaluation. In this case, the exception is a zero division error. And once again, it causes our program to stop dead in its tracks. There are a couple new concepts in this video. The first you've already learned about. Ta-da! Exceptions. Exceptions are runtime errors in a program. By default, they stop the program. Python has a way of letting programmers handle exceptions, and this is try and except. Try and except are programming constructs that can be used to gracefully handle exceptions so that a program can continue in spite of them. Here's the program from the last example with try and except thrown in. Here's the way it works. If you have some code that might raise an exception, you can put it inside what's called a try block. You then follow it with an except block, which specifies the type of exception you want to handle. The block contains code that will run if an exception is raised. Let's step through this. First, we ask the user for a numerator and they enter 10. Then we ask them for a denominator and they enter 0. Now we enter the try block. Since the try block is paired with an except block that can handle a zero division error, the interpreter will jump straight to the except block if a zero division error happens. The interpreter tries to evaluate this division expression in order to assign to quotient. And oh no, a zero division error exception is raised. The interpreter skips the rest of the try block and goes straight to the exception block. Then the print in the exception block runs, and the interpreter can continue as normal. Going back to this example, let's use try and except to make sure the error is handled gracefully. Here's an almost complete version of the program. We just need to fill in what type of exception we want to handle. It's not zero division error, that won't work this time. In fact, if we use zero division error, since that type of exception is never raised, and another type of exception is raised, it's basically like we didn't use try and except at all. Look at the error message. What we should be handling is value error. Now, when the user enters letters and the value error exception is raised, the interpreter can jump to our except block, which comes in and saves the day. The print executes and the program can continue as normal. In this module, we've seen a number of programs in which the interpreter doesn't move sequentially. It jumps around. Exceptions are another way in which the interpreter can jump in a non-sequential manner. Let's use our knowledge of exceptions and exception handling to write a robust program that asks a user for their name and age. So I'm going to write this the naive way first. I'm just going to say name is input name, age is, and I'm going to convert what they enter into an int by saying int input age, and then I'm just going to spit it back out at them. Name, age, and I'm going to convert age to a string. All right. So if I say my name is Lee, my age is 32, no problem. If I say my name is Lee and my age is not a number, then we get an error. So let's try to use try and except to catch this error. I'm going to say try here. And the type of error I want to catch is going to be value error. And in this case, I'm going to print age must be a number. All right, let's try this. Name Lee, age 32. Okay, that still works. Name Lee, age, bunch of letters. Okay, so it prints age must be a number, and it successfully prints the name back out at us, but then it has an error right here. It says age is not defined on line 8. Now, we could make another try except that handles name error, but instead, let's just give age a default value of -1. And if we do this, we know that if -1 appears in the output, that means that the age that was entered was invalid. So let's try this. Let's do Lee and 32 again to make sure that still works. Now let's do Lee and not a number. and it says age must be a number, and it successfully prints back out the name, and age is -1. Now let's add some comments. This program retrieves the user's name and age. Retrieve the name. No need for exception handling. Here we'll say default value for age. Retrieve the age and handle case where the user does not enter a valid number. And then finally print name and age.